Hello friends, welcome to Susan and John MathTube. This is the second part in reduction formula, and again I'm telling you this is very important for the architecture students in TU. Okay, with that let's start the next one, integral tan to the power nx dx, and I'll strongly recommend don't watch this video if you have not watched the introduction and integral sine to the power n x dx, because I gave all the concepts etc. in that. So like I told you before, the first thing to do is you have to call this integral as in, and we are intentionally doing that so that this power and the name will be connected. Okay, and I told one more thing yesterday, that is reduction formula is a systematic method where we create steps. And remember, we can call a formula reduction formula if you write the bigger index in terms of a smaller index. And normally we tend to write in terms of in minus 1 or in minus 2 or in minus 3. If you write in terms of in minus 1, you should imagine a person who is moving downstairs step by step. So it takes time to reach the bottom of the floor. But at the same time, if someone is moving like what you call 2 steps at a time, they will reach faster. And that is exactly our in minus 2 that you saw in the last video. Okay, one more thing, one more very important thing. If you understand the method for sine, then the method for cosine is similar. And if you understand the method for tan, I don't have to teach you the method for cot. Of course, there will be a difference in plus or minus, but the majority will be the same. Okay, so the method is very simple. It is based on laws of indices. A power n is a power n minus 2 into a square. And with that enlightenment, I am going to write this as n minus 2x into tan square x. And I know that tan square x is nothing but sec square x minus 1. Isn't it? And that will be, now we have to apply distributive property and open the bracket. So we get integral tan to the power n minus 2x into sec square x minus tan to the power n minus 2x. In is equal to, now I am going to split this integral. Integral tan to the power n minus 2x into sec square x dx minus integral tan to the power n minus 2x dx. That is, in is equal to integral tan to the power n minus 2x into sec square x dx minus, now look at this. In the last video also I showed you, when you get something similar to the question, when you get something which looks like the question, but if the power is different, immediately you should take a look at the question and identify that character. And it is obvious that is nothing but in minus 2. Okay, so we already have the reduction formula because we are writing in terms of n minus 2. But wait a minute, we have one more thing to do. We have to evaluate this integral. And to be honest, compared to sine cos, this proof is very easy. Okay, and I'm sure anyone who was good in class 11 and 12 in integration will tell me what to do next. Think about it, please. Tell me, what exactly should I do? Can you see a function and its derivative. Yeah, in such cases what we do is we go for substitution method, that is we put tan x is equal to t, and if you put tan x is equal to t, then we get sec square x dx is equal to dt, and that means in is equal to, look at this, integral t to the power n minus 2, because tan x is t, and dt minus in minus 2. That's it. We are almost at the end. In is equal to t to the power n minus 2 plus 1 by n minus 2 plus 1. And that gives me, don't forget the value of t, it's over here. What is t? Tan x. So we get in is equal to t to the power n minus 1 by n minus 1 minus in minus 2. That is, in is equal to t is tan x, so tan to the power n minus 1 x, the whole divided by n minus 1 minus in minus 2. Okay, that's it. So we have the reduction formula. But I told you something very important in the last video. Don't leave it as such. Maybe you'll get 5 marks out of 5 marks. But to be honest, or to be more mathematically precise, this is not the reduction formula. In my opinion, reduction formula becomes the reduction formula only when you write the ultimate integral. Now look at this. We are reducing in into in minus 2. That means you should imagine someone who is jumping 2 steps at a time. You have to imagine someone who is jumping 2 steps at a time. You got the point, right? Now think about it. If you start with an even number, let's say 6, the next jump will take him to the 4th step, and then to the 2nd step, and of course to the 0th step. That means if n is even, then the ultimate integral, the final position, the last person will be I0, and that will be nothing but tan to the power 0x dx. Don't worry about this step, I'll show you. I0 means you should replace n with 0. Any finite number to the power 0 will be 1. So this becomes 1, and 1 into dx is dx. And that will be x plus c. If n is odd, I'm not going to explain too much because we already saw the same thing. So we get I1. So tan to the power 1x dx, that will be log sec x to the base c, that is natural log of sec x plus c. That's it. So this is a more mathematically ideal answer. Okay, now let's do one example. Suppose you want to evaluate tan to the power, let's say 4x dx. So what I do is I identify or I compare with the question. Okay, this is nothing but I4, because tan to the power 4x will be I4. Okay, next thing I do is I'll take the reduction formula and I'm going to keep it on one side. I want that, so I'll circle n wherever it's available. Okay, now look at this. Suppose I want I4. So what I do is I replace n with the number 4. So I get tan to the power 3x by 3 minus I2. This will be tan to the power 3x by 3 minus, I want I2. So put a bracket. Now I have to replace n with 2. So tan to the power 2 minus 1 by 2 minus 1 minus I0. Okay, we have the ultimate integral, because I told you whenever you start with an even number, ultimately you will reach I0, and that is x. So we get the answer tan cube by 3 minus tan x by 1 plus, because minus and minus will be plus, x plus c. Isn't it really easy? Okay, so time to give you a work. Find a reduction formula for cot to the power n x dx. It will be similar to tan, and hence you evaluate integral cot to the power 7x dx. Try it. If you have doubt, you can email it to me, and if you get the answer, please do put it in the comment section below. Anyway, I'll be back with another video in which we'll be discussing about sec to the power nx dx. So as always, if you like the video, please share and subscribe. I'll be back soon. So till then, my friends, bye.